Hello everyone, this is Vishwesh and we are in the series of videos on aptitude skills. In this video we are going to deal with the topic quantitative aptitude and the topic is probability. So let's start with it. So in this video we are going to see first the concept of probability with examples, key strategy to solve these questions, the probability questions, and obviously few practice questions from low difficulty, medium difficulty and high difficulty. So let's start with the concept part. So basically probability is actually the chances, that how many chances are there that the desired event will occur as compared to total possible ways or the outcomes. So here the formula is probability of event A, we can say event A to occur. Probability is number of times A may occur, the desired event may occur, divided by total possible outcomes. Now to understand this formula, let's take the example of coin. So basically every coin or a coin has two sides. One is head, other is tail. So when we throw a coin, when we toss a coin, generally either we should get head or we should get tail. Okay, there are very few chances that it will stand vertically, but mostly we will get head or tail. Now in this, if we are desiring, if we want that it should be head always, or whenever we toss a coin we should get head, what is the probability that we should get head? Then the desired event is head, which is number of times it is 1, and total outcomes are either head or tail. So two total outcomes are there. So here total outcomes will be 2 and hence probability will be 1 upon 2, which is 0.5. Now here one thing you can note, that probability is always between 0 and 1. It is always between 0 and 1. It will be never more than 1 and it will be never less than 0. Okay. So this is how we can calculate the probability. In case of dice also, we have a cube. Basically dice is a cube and it has 6 faces. So on each face the numbers are there or dots are there, like 1, 2, 3, 4, 5, 6. Such different dots are there or numbers. And when we throw this dice, this cube, when we throw on the top surface, we will get either 1 or 2 or 3 or 4, 5, 6. Any face can appear. Any one of the face can appear on the top. Now let's say we desire that we want 3 only on the top of the face. We need 3 number or 3 dots. Then the probability will be number of desired events are 1. This is 1 on this, so 1 divided by total possible outcomes are 6. So this can be the probability 1 by 6. Moreover, if we desire that we are ready to accept 3 or 6. So desired events are, we can have 3, it is accepted, or we can have 6, this is also accepted. So desired events are 2 in this case, hence the probability will become 2 divided by 6, or it is 1 by 3. So this is how probabilities we can calculate. Now talking about the adjoining concept with this probability topic, and that is permutations and combinations. Many times we need to take help of combinations, sometimes we need to take help of permutations also. So basically combinations are the selection part, and permutations is all about arrangements. Okay. So here it is given in the explanation, combinations refer to selection and permutations take order into account. So basically how we can calculate permutations can be calculated by using this formula, NPR is equals to n factorial upon n minus r factorial. Combinations can be calculated by using this formula, NCR, which is n factorial upon n minus r factorial into r factorial. Now how to use this, we already have one video on this, and in this topic also we are going to use this formula NCR, so there also this concept will get cleared. So Understanding this probability formula is very important. Now moving forward, the key strategy to solve these probability questions is on the basis of this formula only. So what this formula is, understanding this formula in detail, logically we have to understand it, and then you will be able to solve any question for this topic. So what this formula says, that number of times A occurs, if desired event is A and number of times A occurs divided by total number of possible outcomes. So basically we are comparing the desired result, the expected result with total possibilities or total possible outcomes. And by comparing this we get a fraction, and this fraction is always between 0 and 1. This is nothing but the basic of this formula. So basically we are comparing the desired result with total possibilities. For example, a coin, just we discussed on the last slide that coin has two sides, head and tail. So either we can desire to get head or we can desire to get tail, or we can also say that I need either head or tail. So in this case desired events are 2, probability is equals to desired events are 2 and possibilities are also 2. So probability of getting either head or tail is 100%. If we calculate it in percentage or in fraction, it is 1. That means it is for sure that either you will get head or tail. There is no other outcome. So this is how we can use this formula, understand it first, and we can use this to solve any question. So that is the key strategy here. Let's start with now the questions. So we are going to start with low difficulty question first. Let's read the question. Tickets numbered 1 to 20 are mixed up and then a ticket is drawn at random. What is the probability that the ticket drawn has a number which is a multiple of 3 or 5? So what is given? We have tickets. Let's say these are the tickets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 tickets are there. So let's write the remaining numbers also. 13, 14, 15, 16, 17, 18, 19 and 20. So these are 20 tickets. Okay. Now out of these 20 tickets we are going to draw, or we are going to take out only one ticket. A ticket is drawn. Okay. Here it is mentioned. A ticket is drawn. So a single ticket is drawn. But condition is whatever ticket we draw, it should be multiple of 3 or 5. So out of these, 3 is acceptable event, 6 is also multiple of 3, it is also acceptable, 9 is also acceptable, 12, 15, 18 and that's it. 21 is not here. So these are acceptable, these are multiples of 3, so we can accept this. So when we calculate probability, the numerator will be 1, 2, 3, 4, 5, 6. Okay, 6 can be the numerator. But here what is mentioned, it can be 3 or 5 also, multiples of 3 or 5 also. So multiples of 5 also we need to find out. So 5 can be 1, 10 can be there, 15 we already have highlighted it, and 20 also can be there, right? So desired events or desired results are 1, 2, 3, 4, 5, 6, 7, 8, 9. So numerator can be 9, and total possible outcomes can be, whenever we draw a ticket, it can be 1, it can be 13, it can be 6, it can be 17, it can be anything. From 1 to 20 it can be anything. So total desired outcomes or total possible outcomes would be 20. And this answer 9 by 20 is correct, which is option D. I hope you understood this. Let's go to next question. Now this next question is again of low difficulty level. Let's read it. From a pack of 52 cards, 2 cards are drawn together at random. What is the probability of both the cards being kings? Okay, so 52 cards are there, and out of 52 we have to draw two cards. So the two cards may be any two cards, but what the desired outcome is, these two cards must be kings. Okay, now from 52 cards, how many kings we have in it? So different suits are there, and out of those 4 kings are there, correct? So when we calculate probability, out of 4 we can have 2 kings, but total possible outcomes are, out of 52 cards we can have any 2 cards, randomly we can select any 2 cards, right? Now here we have to use the formula NCR, because this is the part of selection. We have to select out of something. So from 4 kings we have to select 2. From 52 cards we have to select 2 cards. How it can be done? So to select 2 kings out of 4, 4C2 will be the formula. To select 2 cards out of 52, 52C2 will be the formula. And applying the formula, n factorial upon n minus r, so 4 factorial upon 4 minus 2, 2 factorial into 2 factorial, divided by 52 factorial upon 52 minus 2, which is 50 factorial, into 2 factorial. Let's simplify this over here. So it will be 4 factorial upon 52 factorial multiplied by, this will go up and this will go down. So it will be 50 factorial into 2 factorial upon 2 factorial, 2 factorial. Correct? Let's cancel this out over here itself, and this 4 factorial we can split into 4 into 3 into 2 factorial multiplied by 50 factorial will be as it is, divided by 52 can be 52 into 51 into 50 factorial, and this 2 factorial again as it is. So 2 factorial we can cancel, 50 factorial we can cancel. Now this is 51, 52, 4 and 3. So if we divide it by 4, 4 1 is 4, 4 1 is 4, 1 is there, 4 3 is 12. So 13, 5, 4 is 52. And 3 1 is 3, and here we can divide this, 3 1 is 3, 3 1 is 3 here, again 2 is common, and 3 7 is, so 17 3 is 51. So finally what we remain with, 1 upon 13 into 17. So this, let's do this multiplication, 13 into 17 over here. So 7 3 is 21, 1 is there, 2 carry, 3 1 is 3, 7 1 is 7, addition of all these will be 12. So 2 will be part here and 1 carry, 1 1 is 1 and 1 this. So finally the answer is 1 upon 2 to 1, which is option D. Option D is correct. Now in this next question we have medium difficulty level question. What is the probability of getting a sum 9 from throws of a dice? From throws of a 2 dice. Here the word 2 is missing. Let me write it. What is the probability of getting a sum of 9 from, here it is, sorry, 2 throws of a dice. So basically we have 2 dice. So one dice will have outcomes like 1, 2, 3, 4, 5 or 6. And second dice also can have outcomes like 1 or 2 or 3, 4, 5 or 6. Correct? Now when we throw 2 dice, first dice may show 1 and second dice may show again 1. If we throw the 2 dice again, first may show 3, second may show 6. Again if we throw the dice, first may show 4, second may show 1. So this way we can have different combinations. So if first dice is showing 1, second may show 1, 2, 3, 4, 5, 6, any number out of it. So for one of the first dice, 6 possibilities are there for second dice. Similarly, if we select 2 or if we get 2 from the first dice, we may again have 6 different outcomes from second dice. So this way, these 6 outcomes and these 6 outcomes, and if we multiply, total possible outcomes will be 36. 6 6 are 36. Total possible outcomes will be 36. Now what is the condition? We need summation as 9. Now wherever we are getting 9 as the summation, if we have 3 comma 6 or 6 comma 3, so first dice as 3, second dice as 6, or first dice as 6 and second as 3. Maybe 5 comma 4 and 4 comma 5. Here also we are getting summation as 9 in both the cases. Are you able to find out any other combination out of these 4? No. So only 4 combinations are possible if we need summation as 9 from the 2 dice throws. So possible desired outcomes are 4. Desired outcomes are 4. Total possible are 36. So probability will be desired outcomes divided by total possible outcomes, and this gives 9 as the answer. 1 by 9 as the answer. Option C is correct. Let's go for next. Now this is again medium level difficulty question. Let's read it. In a lottery there are 10 prizes and 25 blanks. A lottery is drawn at random. What is the probability of getting a prize? Okay, now I hope you will be able to solve this. So pause the video, try for this question. If not possible to get the answer, you can go through the solution part. So in this case, what is given? 10 prizes are given, 10 prizes are there and 25 blank tickets are there, lottery tickets. And on 10 of the tickets, prizes are there and 25 are blank without prizes. So total how many we have? 10 plus 25. Total we have 35 tickets, lottery tickets. Now the condition is we should be getting a prize. So if we want to get a prize, the desired outcome must be out of this 10. So this must be desired. And what will be total? This will be total. Right? It may be blank, it may be this in case of total. So probability, when we find out, probability is equals to desired outcome, which is 10, and total outcomes is 35. Now this will be 5 2s are 10 and 5 7s are 35. So 2 upon 7 must be the correct answer, which is option C. Let's go to the next question. Now this is again medium level difficulty question. In a class there are 15 boys and 10 girls. 3 students are selected at random. The probability that 1 girl and 2 boys are selected is what? Again I will request to pause the video, try to solve it on your own. If not possible, you can go through this solution. So total 15 boys are there. Let's write it down here. 15 boys we have and 10 girls we have. Okay. So out of 15 boys we have to select how many? 2. And out of 10 girls we have to select 1. And we have to find out that when we select the 3 students, randomly, what is the probability that we get 2 boys and 1 girl? Okay. Now here also we will use same formula. Probability is equals to desired event upon total possible outcomes. Now let's talk about total possible outcomes first. So we are going to select 3 students out of 15 boys and 10 girls. So 15 plus 10 will be, the addition of these 2 will be 25. So out of 25 students we are going to select 3. Correct? So total possible outcomes will be selection of 3 out of 25, which is 25C3 selection. Now here we are talking about selection, and hence we have to use the formula of combination, NCR. So out of 25 we are going to select 3. Now in case of desired event, here we need 2 boys. We need 2 boys and 1 girl. So this and is very important here. We need 2 boys and 1 girl, and it's not or, it's and. So we need 2 boys as well as we need 1 girl. Okay. So desired event, we need 2 boys out of 15. So it can be done in these many ways. 15C2 and is there. So multiplication we need to take, and 1 girl we have to select. So it can be done in 10C1 ways. And then we can start calculating it. Correct. So let's write it down. So it will be 15C2 into 10C1 divided by 25C3. Let's split it using formula. So it will be 15 factorial upon 15 minus 2, 13 factorial into 2 factorial, multiplied by 10 factorial upon 10 minus 1, 9 factorial into 1 factorial, divided by this 25c3, so 25 factorial upon 25 minus 3, which is 22 factorial into 3 factorial. Okay, now this 15 factorial can be written as 15 into 14 into 13 factorial. Let's do it here itself. 13 we can cancel. This 10 can be written as 10 into 9 factorial. 9 we can cancel. 2 factorial is 2 into 1. So 2 ones are 2, 2 5s are 10. So in the numerator, what is remaining? This 15 is remaining and 5 is remaining. And this 14 is also remaining. Correct? Now let's talk about denominator. In case of denominator, we have 25. So 25 into 24 into 23 into 22 factorial. So 22 factorial we can cancel. This 3 can be 3 into 2 into 1. And here we can divide it. 3 ones are 3, 3 8s are 24. 2 ones are 2, 2 4s are 8. So in the denominator we have 25, we have 4 and we have 23. Now let's write it down over here. So 15 into 14 into 5 divided by 25 into 4 and 23. 4 into 23. Correct? So let's start again dividing. 5 ones are 5, 5 5s are 25. Again 5 ones are 5, 5 3s are 5 2s are 4. 2 2s are 4 and 2 7s are 14. Any possibility? No, I don't think so. So what will be the final answer? 7 3s are 21 divided by 23, 2. Double of 23 will be 46. So 21 by 46 must be the final answer, which is option A. Now let's go to the next question. Now this question is of high difficulty. Now although this question is of high difficulty, only thing is the logic is tricky here. Rest, calculations and solving is very easy. Only thing is you should understand the logic. Once you understand it, then it is easy level question. Let's read the question. A bag contains 2 red, 3 green, 2 blue balls. 2 balls are drawn at random. So out of how many? 2 plus 3 plus 2. 7 balls are there. Out of 7 we are going to draw, or we are going to select 2 balls randomly. Okay, what is the probability that none of the balls drawn is blue? Now condition is tricky. As I said, the condition is tricky, that's why it is a little bit difficult, high difficulty level. Condition is that none of the balls, selected ball, none of it should be blue. It can be red, it can be green, but it should not be blue. This is what the condition is. So if you are getting some hints or some logic, try to solve it. So pause the video, try to solve this question. If not possible, you can go through this solution. So as I said, we have to calculate probability. So probability will have numerator and denominator. Numerator is desired event, denominator is total possible outcomes. Now let's talk about total possible outcomes first. Okay, so we have to select 2 balls out of 7. So it can be done in 7C2 ways. Very simple. So we can select 2 balls out of 7 in these many different ways. Now let's talk about numerator. In case of numerator, we don't want blue ball. We don't want blue ball. We can have red, we can have green. So red and green total balls are 5. So out of 5 we can select any 2 balls. So it can be done in 5C2 ways. And this is the solution. So here numerator is desired event. We are not drawing any blue ball. But we can have red and green. Red or green. Or one red, one green. It can be anything. So total 5 balls are there. 5 out of 5 we have to select 2. It can be done in these many ways. Denominator is 7C2. Out of 7 balls we are selecting 2 balls. Let's simplify it. 5 factorial upon 5 minus 2, 3 factorial into 2 factorial divided by 7 factorial upon 7 minus 2, 5 factorial into 2 factorial. Simplifying it, 5 factorial can be 5 into 4 into 3 factorial upon 3 factorial into 2 into 1. So 3 we can cancel here. Then in the denominator 7 into 6 into 5 factorial divided by 5 factorial as it is into 2 into 1. So 5 factorial we can cancel. 2 ones are 2, 2 3s are 6, 2 ones are 2, 2 4, 2 2s are 4. So finally we get 5 2s are 10 in the numerator and 7 3s are 21 in the denominator. So 10 by 21 must be the correct answer. Option A is correct. Now let's go to the last question of this topic. Again, it is of high difficulty level. And what is it? 3 unbiased coins are tossed. So 3 coins we have. Coin 1, coin 2 and coin 3. Coin 1 will have head and tail. Coin 2 will also have head and tail. Coin 3 will also have head and tail. Now we have to find out probability of getting at most 2 heads. Now as I said, the logic is tricky. So this logic is also tricky. The at most 2 heads we need. At most 2 heads. So maximum we can have 2 heads. 2 heads. Okay. Now when we are tossing 3 coins, first coin may have head, second may have tail, third may have tail. First may have tail, second may be H, then T. So this way we can have different combinations. Let's find out these combinations first. So we can have HTT, THT, or we can have TTH, correct? Or we can have HHT, or we can have HTH or THH, correct? Any other ways? And we can have TTT as well as we can have HHH. So this is how first coin, second coin and third coin. These are the different possibilities. So how many these are? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 possibilities are there. Except these 8 possibilities, there will be no possibility. We have covered all the combinations. We have covered here all the combinations. So total possible outcomes, when we calculate probability, total possible outcomes are 8. Okay. And the condition is we need maximum 2. We don't need 3 heads. We don't need 3 heads. We can accept 2 heads or 1 head or 0 heads as well. But we don't need 3 heads. So 3 heads is here, except 0 head, 2 heads, 2, 2, 1 head, 1 head, 1 head. So we can have all these as the desired outcomes. 7 will be the desired outcome and total 8 possibilities are there. This is not desired outcome. So 7 by 8 must be the final answer. Option D is correct. Going further, I will request you all to practice as many questions as possible, and practice will make you confident in this topic. So let's end this video here. Thank you.